Technically speaking, technically speaking, I ain't talking vegan when I said that I've been eating, making money on the side, but I use it for the main. I'm speaking in code when I tech talk that financial freedom. Have a seat cause you gon' wanna sit up at my table, yeah. Plugged in that it, girl, IT with the cables, yeah. Network engineering is for you, it ain't no labels, yeah. Shaky with my passion, took a leap, it got me stable, yeah. Now I make 100K or better, paper couldn't fit a stapler, and I spend it on my passion cause I'm capable. Technically speaking, now I'm really talking vegan when I said that I've been eating, I've been technically speaking. Technically speaking, China white. When I've been said I've been technically speaking. Said I've been technically speaking. China white.
Guys, to another lesson with the CCNA exam prep course. Yesterday we talked about lesson 1.3, 1.4, 1.5 here, and we're going to talk about IP4 addressing. This will just be one lesson about IP4 because there's a lot to cover. But I'm going to keep repeating myself. Please make sure you are taking handwritten notes. Okay, I want you to have your notebook, a piece of paper, a pen or a pencil, and write down these notes. Okay. And then if you do need a PDF or an type of article for reference, I can definitely give that to you. But if you just go through this and actually write through notes as I am speaking, you'll be able to catch everything. Okay. So we're still in network fundamentals, right? And then we're gonna go over, let me just make sure. We're gonna go over 1.6, configure and verify, IP addressing and subnetting. And then we'll talk about the need for private IP4 addressing. Okay. Now, subnetting, we probably won't get too deep into it. It's probably gonna be a couple of questions on it, on the exam, but it's good to know what it is about, what is subnetting and how to subnet. And then later on, we'll probably do some practices, so you can at least be able to do a couple exercises, okay? So let's get into IP4 addressing, IPv4 addressing. So let me bring up, let me see, maybe I want to show you an image. I think we all know what an IP address is, an IP address is, or IPv4. This is what it looks like, right? It's something as such. It's separated in 4 sections, right? We have 4 different numbers and they separated by decimals or dots. It can look something like this: 172.16.254.1. Okay, it's a combination of numbers between 0 and the highest number will be 255, right? So you'll see nothing more than 255. Okay, but this is like a regular IPv4, and we're going to talk about that. So an IP address, we talked about the OSI model, and IP addresses work on the network layer, the third layer of the IP address, third layer of the OSI model. And this IP address helps us, it's like our, it's like our address that helps us navigate the internet. IP stands for Internet Protocol. So it is our Internet Protocol address that allows us to navigate the internet and talk to different folks, okay? Because we need an address to send messages, to send data. I like to think of it as like a letter, okay? When you are sending a letter or you're sending something through mail, maybe a package, or you're trying to get a package, let's say you ordered something off Temu or something, they're going to ask you for your address, not just your name. And the first part of your address, for example, 123 Main Street, is something like your physical address. And then we have your global address, or an address that can be globally recognized, which is your state, your city and state. So it may be Houston, Texas. And then of course you have a zip code, right? Zip code can be 77018 or something, right? So That's like an IP4 address. It's their city and state and your zip code, so we can ensure that we got to the right place, because Houston, Texas has multiple zip codes, right? Or you could just put Texas and has multiple cities. So we want to be very specific, and that's what our IP address is for. Now we have V, the letter V, and V is version. That's what that stands for. And then the number 4 is the number 4. So if we put it all together, we have Internet Protocol version 4. It is the 4th version of the internet. It's really all it is. All right. Now, an IPv4 address sends information 3 types of ways. It can send it in a unicast way, which is like point to point, right? Which is to one person. I want to send a message only to my coworker, Sarah. I want to send a message to only my boss. I want to send a message to only my friends, only my grandma. Then we have multicast, right? That's more like a group message, you can say. I want to send a message to my boss and my colleague. I want to send a message to my grandma and my auntie, right? And then we have broadcast. Broadcast is sending it to everybody. Everybody who's connected on the internet, you'll get it. And I like to describe it as like an Amber Alert, right? Like it's just going to everyone's phone, right? Like everyone gets it. It's a broadcast message. Okay. Those are really the 3 types of IP addresses, IPv4 addresses, that you need to understand, that will definitely be on the exam. But it's also good to know as we are going out and becoming IT professionals, right? If someone's saying that they're unable to send a message to someone, you want to know, all right, this unicast message is a group message. Do you have group settings? Is it just to this one person? Can you send it to other people? Are you trying to broadcast a message? Do you want to send like a mass text alert or a mass message alert or whatever the case may be? You want to know these 3 ways to send data via an IPv4 address. Okay. Now, we do have what's called private IPv4 addresses. Why are they private? Okay, so when the internet first came out, IPv4 addresses, again, hence the 4th version, they were able to assign everyone their own IP address to use the internet. Okay, but then technology kept advancing, and then we started needing phones and other types of computing devices, watches, microphones, cameras, you name it, right? All of these devices are now needing Wi-Fi capability. They can now get on the internet. That means that they need an IP address. And if our IP addresses can be a combination between 0 and 255, there's only so many IP addresses we can give out in the world, right? Like we're going to end up running out. Well, we actually did run out of IPv4 addresses. So what do we do now? So what the internet police decided to do was they decided to reserve a pool of addresses, of IPv4 addresses, what we call private, so you can use that private address when you're offline. So I can have the same IP address as you, as my boss, as my grandma. We can all have the same private IP address, because private means it's not going public. It's not something that we need to route on the internet. We just need an address to talk locally in our own network. So as long as the folks in our own local network don't have the same IP address, which is pretty simple, if we have like 20 devices, we can come up with 20 IP addresses privately. But once we go out into the internet, we want to actually talk to people outside of our local area network. We're going to need a public address. Okay, so basically, the private addresses is just reserving addresses so we don't take up resources. So if I'm not on the internet, my public address will be recycled to someone who does need to get on the internet, right? And when I am working on my computer, let's say locally, I'll have a private IP address. Or for a better example, you're working as a network engineer. Inside of your network, we have servers. We have a phone server, an email server. We got all these servers, right? These servers will have a private address. It will not have a public address because these servers should only be dealt with privately, should be only dealt with locally, right? Only the people that work at the job, and specifically the people in the engineering department, right? And specifically the people who deals with that specific server should have access, right? And it can be locally. We do not need the internet to access our email server or our voice server. So we have private addresses. So that allows us to allocate IP addresses and use the internet more better, right? More effectively and efficiently because we are not fighting over IP addresses. Now, tomorrow, we will talk about IPv6 addresses. This is the version 6. This is the latest version. You may see that, well, you will see that you have version 6 IP addresses now going around, but we have enough different ways that we can still use IPv4. So, they say that IPv4 is back in the past. We're not using it anymore. We ran out of IP addresses. But if you look in your, device, you're kind of savvy, you can kind of see that we still use IPv4 addresses. So they're really not going anywhere. Why they're not going anywhere? Because we got things called subnetting. We got things called NAT, network address translation, which is translating a private into public and a public into private. So we have these things that can help us continue to use IPv4. But technology is going to keep advancing. The IETF, which is the Internet Engineering Task Force, we call them the Internet Police. They say, hey, this is how we're going to allocate this, and we're going to come up with a better version, which is version 6. Okay, and this version 6, we'll talk about it more, but you'll see the difference. So just looking at this little diagram here, they have your IP address in different classes, class A, B, C, D, and I think E and F, they're not showing it, but these are the classes for private, right? It's kind of a little foreign to you, but we will go in and talk in depth so you can understand what a class A is, what private address range. You see it starts with a 10, you see this starts with 172, 192, you see a /8, 12, 16. We will definitely go more into that. One moment, sorry. Okay, so let's go down here. Now, before we even go to subnetting, how is your IP address allocated to you? How do you get that? You can get an IP address two different ways. You can get it by your internet service provider, your what we call ISP, internet service provider, AT&T, Comcast, Xfinity, who knows? But they will say, hey, this is your IP address, right? They will allocate that to you. Or you get it statically, right? You can say, hey, I'm going to assign myself this IP address. Now let's look at it as if we were network engineers. How does the company get IP addresses? How are we able to assign HR their IP addresses, and the development team the IP addresses, and the executives IP addresses? Okay, now again, we will get a pool of IP addresses from our internet service provider, which will be on a more corporate level. So it wouldn't be AT&T or Xfinity. It'll be companies called Bandwidth or Lumen. Those are really the two big internet service providers that at least I've worked with in every company. When I worked with T-Mobile, we worked with Lumen. When I worked for a hospital, we worked with Bandwidth. But all other contracts I've had, it's always been some either Bandwidth or Lumen or one of the two, unless it was international. So that internet service provider will say, here's what we have, this pool of IP addresses. We will take that pool of IP addresses and we will break them up. Subnet is what we call. And mostly we have a subnet calculator, so we really don't do this by hand, but I'm going to show you just so you can know how to do it. And then we'll use a protocol called DHCP. And DHCP is a server that basically allocates the IP addresses. We just put what our internet service provider gave us on this DHCP server, and the DHCP DHCP server says, hey, this device connected to the network, I'm going to give you this IP address. This device connected to a network, I'm going to give you this IP address, right? So how we allocate that, again, we get IP addresses from the internet service providers. You may work for an internet service provider, and you may see how they accumulate those IP addresses, which is through other means, or instead of getting it from the internet service provider and they just, give it to you, you can statically set one yourself. It could be private. Most of the time it's private if you're setting it yourself. If it's public, you're gonna probably, a public address, yeah, you're gonna have to talk to an internet service provider, period, for a public IP address. They're either gonna have to give it to you and you set it yourself, or they will automatically assign it to the device connecting to the network, okay? So as you can see, let's say you have an Apple Watch and you're connecting it to Wi-Fi, or you have like a Ring camera, you're connected to Wi-Fi, you're not putting in an IP address. When you connect to your home Wi-Fi network, your Wi-Fi network will automatically assign your Ring camera an IP address, right? You don't even have to understand what IP addresses is for your Ring camera to even get that and connect. But we are network engineers, we're trying to get into tech. So we need to know, how does that Ring camera even get access to the internet so I can download the app on my iPhone and look to see who's at my front door, right? That's all done through the internet. That's all done through IP addressing, okay? All right, so let's talk about subnetting, okay? Now, before we go in, it's really important to understand when we break down numbers and computer language and the difference between computer language and our language. Now, yesterday I talked a little bit about it, but we'll go in some more today. Computer language is called binary, ones and zeros, ones and zeros, ones and zeros. One means on, zero means off, right? So ones and zeros, ones and zeros. I made a reference last time about the Matrix, the movie The Matrix. And as you can see, in the Matrix, they had a bunch of like black screens, and it was like greenish neon type of numbers. And it was really just a whole bunch of ones and zeros. I think even probably like the beginning of the movie, it kind of shows like ones and zeros raining down and stuff, or even when they're switching from like fighting or switching from different scenes, because they're in computer simulated, it's all switching and the lines are ones and zeros, ones and zeros. That's called a computer, right? That's computer language. So when we say an IP address, this is the example, it's not pulling up here. This is the example IP address, 172.16.254.1. The computer reads it in ones and zeros, okay? Now, one and zero, a one and a zero is called a bit, right? A bit. A one is a bit, a zero is a bit. That's all you get, ones and zeros and a combination of such. Now, in each decimal, as you can see, each section, there's 4 sections in each section has 8 bits. So this 172 has 8 ones and zeros, okay? Those 8 ones and zeros combined create what's called 1 byte, all right? So that's where we get megabytes from, or kilobytes, or gigabytes, right? So ones and zeros is computer language, no matter what you say. If you're trying to say something, well, to make it easier, think of Morse code, right? Morse code, you can send a whole message, please somebody come help me, but it is in the communication of beep, 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 right? Those are ones and zeros, okay? Ones and zeros is a code, comes together, you tab that code, you write it out, and it ends up becoming, come save me, my boat is drowning, or something, I don't know. But you definitely need to understand that computers talk in ones and zeros, right? That is called binary. So when we're talking about subnetting, we are taking a full IP address and we are breaking that address up into multiple different little addresses, right? Think of it as, think of it as the number 10, number 100, think of it as a whole number. We want to break that number up. Why do we want to
In
break it up?
today's fast-paced world of technology, staying ahead of the curve is essential for success. But with the ever-expanding landscape of IT certifications, mastering the right skills can seem like a daunting task. Introducing Tech Exam Mastery, your ultimate solution for conquering IT certification exams with confidence. Whether you're aiming to become a networking guru, a cloud computing expert, or a blockchain innovator, Tech Exam Mastery has you covered. Our meticulously curated notes provide in-depth coverage of key concepts, organized in a clear and concise format, saving you time and effort in your exam preparation. Join the thousands of IT professionals who have unlocked their full potential with Tech Exam Mastery. Accelerate your career growth, expand your skill set, and boost your earning potential. Don't just adapt to change, lead it. Tech Exam Mastery. Comprehensive prep notes for IT professionals. Click the link below to learn more.
Because we want to allocate that to other, for instance, people. Let's say we have a full sheet cake, right? A whole cake. And this cake, we can cut it up into 10 pieces. So we can give it to 10 kids. Or we cut up into 20 pieces and give it to 20 kids, right? We could cut it in half and only have two. It's really a big chunk if you could eat one whole half of a cake. So we would, cut it into pieces. And that's basically what subnetting is when it comes to IP addresses. We're taking one whole IP address and we are breaking it down so we can allocate it to different devices, right, on a network. Because we can have one whole IP address, but this IP address can actually be broken down for different networks, all right? It'll come a little more full circle as we continue to learn about routing and routing in the internet and protocols, because we're going to get really deep into that. But right now, you just need to understand that IPv4 addresses, I want to be very specific, that is the version 4. Because version 6, we don't do any of that subnetting, okay? Because it's very, very different. What this right here is not something you're going to do in real life. We have calculators that do that, that break all these IP down. So we ain't even got to do none of this crazy little math. But it's good to know because one, since so much of this AI is coming out, so much of the calculators and everything is coming out that we don't really need to do this. But if you understand how to do it without needing help, aka AI, then one, it gives you more money. Two, it makes you a better engineer. And if you work for an internet service provider, you'll probably do some instance of this, right? I worked for internet service provider probably like 6-8 months, but I didn't have to do binary. In my 4 years in this career, maybe I had to do binary once, and that was because we didn't have internet service. So of course I couldn't Google anything, I couldn't use AI. So I had to, pull out a good old piece of paper and pencil and do some math here. But the math was literally counting, adding and subtracting. That's really the math. If I wanted to make the math shorter, I could multiply and do multiplication and division. Like I said, I'm not good with math, so I'm able to still be successful without doing all of these adding and subtracting. Even though it's very simple, you can use a calculator on your phone to do it. It's just really good to have a solid understanding what subnetting is and a solid understanding of decimal versus binary, binary versus decimal, okay? So binary, ones and zeros, that's it. 0 means off, 1 means on. So let me pull up this right here. Actually, I think I have a better, yes, I have a better diagram here. So let's take this IP address, 192.0.2.1, okay? Let's look at the first section because it's separated by dots, okay? Now this first section, it has 8 ones and zeros. That's the binary of it. The decimal of it is 192. The binary of it is ones and zeros, okay? How do we know where to put the 1 and where to put the 0, okay? So that's what we're gonna talk about. So these eight ones and zeros actually have place marks. Just when you think of math a little bit, place marks is like the tenths, the thousandths, the hundredths, right? So if you look at let's say when we are talking about money and we have 52.52, you're going to say that's $52.52. Okay, so it's place marks. You know that these are cents and these are dollars and these are like tenths, these are hundredths. So if you have 3 digits, what is that? In the hundreds. If you have 4 digits, it's in the thousands, right? So we talk about 6 figures, getting 6 figures. How many is that, right? How many zeros is that? Okay, cool. So we can visualize what numbers look like when they are in certain place marks, okay? Same thing with binary. So binary, we have 8 place marks, okay? These 8 place marks, I like to start at 1. Some people start at 128. It doesn't matter. These are the 8 place marks. Please make sure 1 is to your right and the 128 is to your left. For me, how I was able to learn this was I would take 1 and I would just double it to 2. I would double that to 4. I would double that to 8. I would double 8 to 16. I will double 16, 16, 16, 32. I will double 32. What is that? 64. Double 64, 128. All we care about is the 8 place marks. That's it. That's all is 8. So if you start at 128, you know minus the 2. You minus, you divide it by 2. And you keep going down until you get to 8 place marks. Okay, that's how what was able to help me understand the binary into decimal. These are the place marks. So when we have the ones and zeros, how do I know? Again, 1 is on, 0 is off. Let's have another analogy. 1 means count, 0 means do not count me. Okay, so we have our 192 in our first section. Now, what this section is called is an octet, right? Like octagon, we have 8 sides, octet, because it's 8 placements. So we have 4 octets in an IP address. We have to work with 1 at a time. So the first octet is 192, and we need 8 ones and zeros, right? Ones you count, zeros you do not count.
Grammatical
So
correction.
can you guys mute, please?
Email us the most you will have.
Who's unmuted here? Angela, can you please mute, please?
Oh, okay, sorry.
All right, thank you. Okay, cool. So I have 8 place marks, 8 ones and zeros. Okay, these place marks, we understand zeros you don't count. Okay, so this is the place mark. Why is this the place mark? I don't know. Maybe you should Google it and learn the science behind why they give you these specific numbers, right? There's some math behind it. We ain't gonna go down that deep. But these are the place marks. So what we want to do is have the ones and zeros, when you count them and you don't count them, they all add up to this whole number, 192. Okay, so it's just adding and subtracting. So we want the ones and zeros. I want you to put a 1 into all the place marks, but either one of these 8 place marks, 1 into what you're going to count to make up 192. Okay, so for an example, right? For an example, we have 128. Now I say, this is how I do it. Now, when you go out into YouTube land and Google land, you may find that people subnet a little different. Since math is not my greatest subject, I break this down as simple as possible, right? My math brain doesn't go as far as a 5th grader. All right, so I have to break it down to where I can understand it and still get the right answer. Some people, they took calculus in high school. I mean, I took calculus, but I failed the class. But some people, actually are pretty good in math. So they are able to understand it from a high level. They do this in exponents type of way. I'm saying that's going to always confuse me. So if you go look online to how to subnet, it may be a little different than this. They will still give you the same information, but it'll be different on how you get to the answer. Because again, people make it more complicated than what it really should. Okay, so 192. The ones and zeros need to equal 192. So we have 128. Can 128 go into 192? Yes, I put a 1 right here. Can 128 plus 64, what does that equal? If we add these two numbers together, that equals 192. Let me pull up a calculator. Let's do that. Let's pull up a calculator. Let's clear it out. And let's do 128 plus 64. 192. Okay, isn't that the number we looking for? 192. So we put a 1 for 28 and a 1 for 64. We're done because we made this number, which is 192. So what you think we can do with all these other mats? We put 0, 0, 0, 0, 0, 0. So altogether, we have 8 ones and zeros. We have 2 ones and 6 zeros. What does that mean for the computer? The computer means that I'm going to count this place mark 128, and I'm going to count this place mark 64. And then I'm not going to count 32, 16. I'm not going to count any of these numbers. So if I don't count that, what do I equal? I equal 192. And that's what it reads in decimal. And that's 1, as you can kind of see right here. I don't know if you can kind of see this. Let me see. Oh, I can. There you go. So if you look, you see that 192 is in decimal, and then in the binary form of 192 is 11000000. Okay? And that one thing right there is what you're going to do to the other 3 octets. So you see this 0 right here? We need to place something in these, in binary. In binary, it's nothing but, because it's 0. So, I mean, obviously, we don't need any number. So it's 0, 0, 0, 0 is 8 zeros. And then 2, right? This is the 3rd octet. It's a number 2, as you can see right here, number 2, 2. How do you say 2 in binary form? Well, can't say 128, can't say 64, so we're going to put some zeros. That's way too big. That's way too big. Too big for 4. 2 is right here, so I can put a 1 in 2. And then that's it, because I made 2 already. So for this 1 place mark, I put 0. As you can see with this binary right here, number 2 is what in binary? 0, 0, 0, 0, 0, 0, 1, 0. Zeros mean you do not count. Ones mean you do count. And 8 place marks, right? And the same for 1. So we have numbers 0 through 255. Okay, so when I first started, in order for me to really understand subnetting for like a whole day, I took whole numbers 192, 164, 172, 10, 7, 17, 89, 92, random whole numbers. Did not go over 255 though. That was my highest number I could choose. So I did 235, 225, 255, 254, right? And just whole numbers. And I would break a whole number down into binary form. How do I break 192 down? How do I break 72 down? How do I break 64 down? Right? I just had to get muscle memory. How do I break it down? It's in 8 bits, which makes 1 byte. Okay? So now that I was able to do that, and I have this here example for the last class, so you can kind of, go through it and see, just reiterate how you turn, the binary into decimal and the decimal into binary, okay? And this is a good one right here. You see, the number 168, these are the values. They do not change. They are here forever. This is what it is. How do you have 168? How do you make 168 into binary? AKA computer language, because computer language don't see 168. It's too big. They don't look at that. They look at ones and zeros to make 168, right? And as you can see, 168 in binary is 1 0 1 0 1 0 0 0. These place marks make a difference. So that's why you have to have it in this form. 1 all the way at the far right and 128 at the far left. And then you have your 6 digits in the middle. How do you know these 6 digits? You can start at 1 and double, or you can start at 128 and divide by 2 until you either get to 8 place marks or until you get to 1, however how you want to understand it. Me, when I first went to go take my CCNA, well, the only time I took my CCNA, they give you like a little whiteboard and like a little dry erase marker. And the first thing I did was I wrote down the 8 place marks. I said 128, 64, 32, 16, 8, 4, 2, 1. And I just left it at that because I didn't need to dump that out of my head, right? In case I forget or whatever the case is, you know. Good for me, it was only 2 questions on the CCNA that asked me to subnet. I don't know if I got them wrong or right, who cares? But it was only 2 questions. So, but they were pretty easy questions. So I felt confident. The point is, you need to understand how to put a whole number into binary, into computer language. Okay. Now, this is a little different from, I forgot the other name of it, but they have ones and zeros that go with letters. So you may also see somebody give you ones and zeros and say, hey, I'm sending you a message, and it's in ones and zeros, and you actually got to break that down, and it'll probably say, hey, I miss you, you know. When I was heavy in doing this, I was a real nerd with some of my Facebook folks, and we would send each other Facebook messages and ones and zeros. I know, very nerdy. But again, when you immerse yourself in this, if you start learning a different way of communicating, it becomes powerful, right? And then you start to want to immerse yourself in it, start to go deep dive in it, and you start to see that it's a whole nother world out here. So educate yourself. But anyway, as we move on, this is kind of what I said already. We do this for all octets. So we see how we did all of that for octet 1. Whew, we got to do it 3 more times. So you can imagine the amount of paper, pencil, and writing you're doing and calculating you're doing. Again, all we did was not multiplication, but addition. Maybe some subtraction, but that's all we did. So it's not like crazy hard. It's just tedious. Okay. And what I tell everybody is before you even go any further, learn that part. Now, the thing too about it is, we don't really do that no more. Okay. That's just old news. We have all these AI systems and we have Google and calculators. We have all these things that can help us. We don't really need to do this type of binary or subnetting, but it's still good to have a solid understanding of this. All right. So I would suggest that that's what you do for today's homework is go over how to break a whole number down into binary, right? I think I have a website that you guys can probably use. I think it's called Subnetting Practice. Let me get this here. That is practice. I want to give y'all this one right here. I think this is good. Now it's basic subnetting questions. Maybe. I'll still send this to you in the chat. Let me send in the chat. May or may not be helpful with this one because I see a couple questions is a little bit advanced. And I would hate for you to get caught up in these questions. Let me see really quick. This one seems, here we go. This is the better one. Disregard that first link. I'm gonna send you the second link. I want you guys to check it. Okay, cool. So use that last link. It'll help you practice. Now, before we go for the second part of subnetting, let's go into the IPv4 addressing when it comes to the classes. Okay. Now, IPv4 has 5 classes that they communicate in, right? A, B, C, D, and E. So class A through C is just used by different bit links. Bit, you know what a bit is. Bit is the ones and zeros, okay? So let me come back up so I can show you the bit links here. Is it up here maybe? Okay, cool. So the bit links, 8. So the first 8 bits is in class A, okay? The first, in this private IP address ring, the first 12 bits is in class B. The first 16 bits is in class C, right? That's kind of the scheme they're going. So when we say bits, what do we talk about? We talked about ones and zeros. A 1 and a 0 is a bit. 8 of them together is a byte. The first 8 is what? The first octet. The first decimal is 10. So this number, the 10 right here, this first octet is all we care about in class A. In class B, we care about the first 12. So this is 8. If we go to the other second octet, that's a whole 8. So 8 plus 8 is what? 16. That didn't say 16, that says 12. So what are you gonna have to do? You're obviously gonna have to understand binary because you have to kick some of those off. So 8 ones and zeros, and then the next you do 11, 12. So it's like the first 8, the first octet, and then the first 2 bits. Again, this is private IP addressing that they are, that is in this diagram. But that's kind of how we use the classes. A through C is by the bit lengths, okay? So the first octet, the first 2 octets, the first 3 octets, okay? That's A, B, and C class. And then we have class D, which is used for like multicasting or like a broadcasting. Again, I'm going to use the same example like Amber Alerts, okay? Weather alerts to your phone. And then E, class E, is used for reserved or the future use. Most of the time the military uses this. So if you're working for the military in some sense, or the government in some sense, you will see class E. We don't use class E. Well, I've never used class E. I never worked for the government. I always worked for private companies. So I haven't used class E before, but you may. And if you see a class E, remember that it's for the government, it's for the military, it's for them folks, all right? Because they be doing stuff. Anyway, so moving on, we have the classes, right? 5 classes. IPv4 uses 5 classes to communicate. These classes are broken into the bit length, okay? Well, at least A through C is through bit length, okay? This D class is like multicasting, broadcasting, and this E class is literally for the government and the military, all right? Boom, that's what you wrote in your notes. Now, an IP address has 2 parts to it. It has a network part and a host part. One part is the network, which means that this IP address belongs to this network. It belongs to a Houston network. It belongs to your home network. It belongs to West Coast network, right? It is the network. It belongs to your job network, right? And then we have another part of the IP address that is your host address. That belongs to the host, you, the client, the user, the actual, I'm not gonna say device because device address is mostly due to your MAC address. But for easier purposes, I'll say it is the end device. It is the host, it is the user. That's the address. So we can say the network is in Houston, but who's specifically in the network? Who's the host in this network? And that would be you, okay? So it's 2 parts, the network and you, okay? Now, when we ask, let's say, someone gives us, I'm gonna say someone, the internet service provider gives us an IP address. And they say, here's an IP address, you can use it for your company. We have 10,000 people in our company, and they gave us one IP address. So what do we have to do? We have to subnet, right? When we subnet, we have to, 1, understand which part of the address is a network part and which part is the host part.